All right. Guess what? It's the second to last day of hearing me lecture. How exciting. All right. Second to last topic that you will ever learn in Algebra 1. And this is, it says more fun with radicals because what would be more fun than that? But this is what we call combining radicals. So multiplying and then adding and subtracting radical expressions. So we have what's called the product rule, and we already know this because we've been doing it with simplifying radicals, right? So it's like if you have the square root of a times the square root of b, you can write that under one radical as the square root of a times b. When we were simplifying, if it was like ab, we would simplify square root of a times square root of b. So we've done this backwards, right? Or this way. Now we're doing it the other way. Okay. So when you multiply radicals together, here's my Vegas rule, right? The Vegas tagline. What happens in Vegas stays in Vegas. Okay, what happens outside the radical stays outside the radical. So here's the thing. If there is a number that's not under a radical, you cannot put it under a radical. Now, radicals, numbers, a radicand, which is the number under a radical, can be taken out from underneath a radical by taking the square root of them, or simplifying it in some way. Okay, so to multiply radicals, we simply multiply the outside by the outside and inside by inside, and then we simplify. Okay, so we have 4 rad 8 times 5 rad 2. So you do 4 times 5 and get, I'm not going to put that there just yet, and get 20. And then you have the square root of 8 times square root of 2. 8 times 2 is 16. Okay, now we have to simplify if necessary. 20 stays 20. Square root of 16 is 4. So this is, we don't need this one. This is just 80. That's your answer. So some of these you'll get, whole number answers like this. Most of them you'll have a radical in your answer. All right, 7 rad 5 times 2 rad 6. 7 times 2 is 14. Rad 5 times rad 6. 5 times 6 is 30. Now you just have to make sure whether, you can simplify or whatnot. So remember we did that before where we would look and see what's the highest number that could go into it. So into 30 would, of course, be 25. Well, 30 doesn't divide evenly by 25 or 16, 9, 4, or 1. So rad 30 is a simplified radical. So we just leave it like that. And then this one's interesting because you think of this as two ways. So you have 3 rad 2 squared. You have to square, remember, just like anything that has multiple bases to it, in parentheses, you have to square each of these. So this will be 3 squared times rad 2 squared. 3 squared is 9. And square root and square cancel each other out, right? They're opposite operations, like multiplying and dividing. So you can just cancel those. This is 9 times 2, which is 18. If you don't believe me, which, you should, but if you want to see it otherwise, remember that to square something is to multiply by itself. So 3 rad 2 times 3 rad 2. 3 times 3 is 9. Rad 2 times rad 2 is rad 4. Well, 9 is 9. Rad 4 is 2. So there you go. This is a quicker way to do it, like this kind of power rule if you want to do that, but it's up to you. All right. Underneath, so we have 3 times 5 rad 2. I have outsides. This one does not have a radical, so I don't have to really do anything there. I just do 3 times 5 and I get 15, and I keep my rad 2. Rad 2 is simplified, so all is good. I have rad 6 times 7 rad 6. And I don't have anything outside of this first rad 6. That's a 1. 1 times 7 is 7. Rad 6 times rad 6 is rad 36. Rad 36, square root of 36 is 6. So 7 times 6 is 42. And then with this one, you could do it either way, where you square both or where you multiply. So I'm going to square both. So I have 8 squared times rad 3 squared. Sorry, I got distracted for like 2 seconds. So what you can do here is 8 squared, which is 64. Rad 3 squared, remember those cancel each other out. So 64 times 3, that's 192. Got it? Cool. Okay. So now we have adding and subtracting. And remember, like adding and subtracting, you have to have like terms, right? So if you have like 6x plus 4x, you can add those together and it's 10x. If you have 6x plus 4y, you can't do anything with that because they're not like terms. So it's just 6x plus 4y. Same thing with radicals. So like terms are radicals that have the exact same radicand. And remember, the radicand, and I say remember, I don't even know if I ever even said this yet this year, is what's under the radical, or the square root, whatever you want to say. So if I'm looking at like 4 times the square root of x, that's not the same as the square root of 4x, right? Because here x is underneath, here 4x is underneath, so those are not like. So if you look at each of these like radicals and unlike radicals, we're just going to throw those in where they belong, right? So 4 rad 5 and 3 rad 5, they both have a rad 5. So those are like. Rad x and rad y are unlike. Rad 3 and 4, rad 2. 3 and 2 are not the same. So it's going unlike. 6 rad x and rad 6x. Ooh, I just kind of did that with the 4s. And I said those are not the same. Because yes, here's an x and there's a 6. And here's an x and there's a 6. But this 6 is on the outside. That one's on the inside. So that does not work. So 6 rad x and rad 6x go in unlike. 7 rad 6 and 7 rad 2. Yeah, your 7s are the same, but the 6 and the 2 are not. And then rad 10 and rad 40. Here's the thing. You might be tempted to say that those are unlike because 10 and 40 are not the same. However, take a look at rad 40. I can split 40 into 4 times 10. And so rad 40 is actually written 2 rad 10. So now rad 10 and 2 rad 10 are the same. So sometimes it's a little bit sneaky and you have to make sure that you've simplified first rather than just say, no, those aren't like terms. I can't do anything with them. Okay, so make sure that you simplify first, which is why, again, it's always a good idea to have that this sheet. Sorry, I lost my words for a second. The simplifying radical sheet out. That can help you quite a bit. All right, so now we literally, again, just do it like we would with x's. So, or y's or whatever, any sort of like terms. So we have 9 rad 3 minus 4 rad 3. Treat these almost as variables, right? I mean, they're not, they're numbers, but rad 3 and rad 3 are the same. So all you do is subtract the coefficient. So 9 minus 4 gives you 5 rad 3 and you're done. Again, just make sure you don't have to simplify anything. 6 rad x and 8 rad y. Is it 14 rad xy? No, it is not. It's simply 6 rad x plus 8 rad y. Because you can't do anything with those two, right? Because x and y are not the same. You cannot change them to be the same. All right, rad m minus 7 rad m. So that's a 1 right in front of that. Just like x would have a 1x in front, or a 1 in front of it. So 1 minus 7 gives me negative 6 rad m. And then E here, 4 rad m plus 4 rad n. Rad n's are the same. 4 plus 4 is 8. That's 8 rad n. All right, part D. I have 2 rad xy plus 2 rad y plus 9 rad xy. Okay, well, I can add these two together because they both have an xy. So I have 2 rad xy plus 9 rad xy, so that's 11 rad xy plus 2 rad y. And I'm simplified now. I can't do anything else with this because these are not like radicals. All right. So F, I have rad 2s minus rad 5s plus 9 rad 5s. Again, these two are the same. 2s is not. So rad 2s, I'm going to keep. And then I have, again, that's a 1 out in front of there. Well, negative 1 plus 9 give me plus 8 rad 5s. All right. So far, so good. Right? And of course, I'm asking you that, and you can't answer me. All right. So I love this little, I'm not a turkey, right? So yes, he is. But anyway, like I said, excuse me, in the beginning of this, sometimes radicals are disguised as unlike radicals, even though they are like radicals. So your rule, like I said on the other side, is simplify all radicals first. And we'll just remember how to do that real quick. So remember, we're simplifying radicals. This is what we did Tuesday. Well, yeah, just yesterday, I guess. And you want to find the largest perfect square that can be divided out. So you need to rewrite 40 as a product of two numbers, one of which is a perfect square. And like I said, the largest perfect square, because then you won't have to simplify it again. So if you don't remember how to do this, you find, so it's 40. So you go to the largest possible number that could go into 40. 49, of course, can't. So you would stop at 36. So it has to be the largest number under the one that you're looking to simplify. So you do 40 divided by 36. And remember, what you're looking for is a whole number when you divide it. That's what you're answering, not a decimal. If you divide 40 by 36, you do not get a whole number. Same thing with 25. You don't. You also don't with 16. You also do not with 9. When you get to 4, if you divide 40 by 4, you get 10. So there's my perfect square of 4. There's my simplified radical of 10. And then remember, you take the square root of 4, which is 2. And since rad 10 is simplified, it stays there. Right? And there you go. Okay. So you have the square root of 125. So now, again, you can go back to this if you would like to. And you, of course, would start at 100 and just start dividing from there. So 125 divided by 100, you're not going to get a whole number. 125 divided by, 81, you're not. 64, same thing. 49, same thing. 36, same thing. 25, you will. So 125 can be written as 25 times 5. So square root of 25 is 5, and then rad 5 stays rad 5. 18, you could, again, start at 16 if you wanted. You would very quickly get to 9. So this is the square root of 9 times the square root of 2. The square root of 9 is 3, and then rad 2 stays. All right, so we're going to need to employ that in our adding and subtracting here on this last page. So rad 45 minus rad 20. Let's take a look here. And a lot of times you can sort of assume that you're going to have like radicals at some point in this if you have to simplify. In most cases, at least like if you, like in these two, you should expect that it wants you to break it down to like radicals, right? And ones like number 3 or number 4 that have more than 2, maybe a couple of them will go together, maybe all 3, who knows. Let's take a look at 45. So 45, you'd try 36 and 25 and 16, and none of those would work, but you'd get to 9, and it's 9 times 5. Now, what I would suggest doing is thinking, because like obviously when you break this down, you do square root of 9 is 3, and then that's rad 5. So what you're looking for to be the same as this rad 5. So if you look at 20, you're like, I wonder if I divide 20 by 5, will I get a perfect square? Of course, 20 divided by 5 is 4. So that little trick did work there. So sometimes when you find the first one, it might just make it a little bit easier to find the second one. That's all I'm saying. So, and then minus, let's see, square root of 4 is 2, rad 5. So now these are like radicals, and I just subtract them. So 3 minus 2 is 1. So I have 1 rad 5, or just simply rad 5. All right. Now, when I have numbers out in front, I have to just kind of hang on to them for a little bit. So I am going to have to split up 75, but this 9 has to stay out on the outside. Same with this 2. And then we'll deal with that in a little bit. All right, so 75, well, that is 25 times 3. Here's what's going to happen on this one, though. When I do 50, 25 also goes into 50, but only twice. So when I get down to all of this, I actually won't be able to add those together because I'll have a simplified rad 3 and a simplified rad 2. But that's all right. We'll figure it out. So 9 times square root of 25, which is 5, and then rad 3, plus 2 times square root of 25, which is 5, and then rad 2. And then remember our rules for multiplying that we just did on the other side. We just multiply things that are outside the radical. Now, you can't multiply this and this and this and this because there's an adding between them. So you just have to look at these as like their own little radicals. So 9 times 5 is 45. So I have 45 rad 3 plus 2 times 5 is 10 rad 2. And again, I'm done. I can't simplify any further than that because that's a rad 3 and that's a rad 2. All right. Let's take a look at this. Ooh, now I have like sneaky letters in here. But what you should see is that this is a y and that's a y and that's a y. So they're going to be part of my simplified radical. Because it's not a y squared or y to the third. I could take out a y squared. It's just plain old y. So it's going to be by itself. So I'm going to kind of violate my own rule of splitting up numbers and letters here because you're really not going to need to do it. And I kind of talk through this here, my process. But what I always do, if you can't tell, like this first step is that I just like rewrite this entire thing with just blank radicals, knowing that I'm going to have to simplify these, right? All right, so 75, we just did that one up here. So that's a nice part about this. A lot of them repeat quite a bit. So I have 25 and 3. And then, like I said, this y is always going to stay part of your simplified radical because you can't break it down anymore. Notice I brought the 2 down, okay? And then 27. Let's see if we can do the 3 trick here. Well, 27 divided by 3, that gives me 9. Perfect. So that's 9 times 3, and then I'll also have my y. I don't know. Will it work for 48 too? Could we get so lucky? 48 divided by 3, guess what? It's 16. So I did get lucky. All of those can have a 3y now. All right, so square root of 25 is 5. So I have 5 times 3y, rad 3y, excuse me. Minus, this little 2 is going to be sneaky here, so I'm going to add another step. So 2 times square root of 9, which is 3, times rad 3y, plus square root of 16 is 4 times rad 3y. And I wrote this so you saw both steps. If you could do this, in your head before and not do a third step, that's fine. So I do still have to multiply those. So I have 5 rad 3y minus 2 times 3 is 6 rad 3y plus 4 rad 3y. So 5 minus 6 is going to be negative 1 plus 4 is going to be 3. So my final answer should be 3 times rad 3y. All right. So now I'm going to do this last one. And again, I have these YZs here. So that is, those are going to be part of my simplified radicals. And then I have 108, 98, and 75. So, okay, 75. Well, let's just do this here. Plus 3, 2, 2, 2, 2, 2, 2. So 75 we already know, right? That's going to be 25 and 3, and then that YZ is going to go in there too. Make sure you extend, like I did, extend that radical so you know that that YZ is under there. So I wonder, because like 108, I'm just not really sure. So I wonder, rather than going through and trying, 181 and 64 and 49 or whatever, maybe let's just try dividing 108 by 3. And if we do that, we get 36. Yay! So I have 36, and then I have 3yz. Now 98, what if I try that trick too with 98 and I divide it by 3? Well, that's not going to work. Unfortunately, you get 32.7. So maybe you already know what the 98 is going to be. But if I go up and I try 81 and then 64, I will get to 49. And I will see that it's 49 and 2. All right, so let's break this down a little bit further. So square root of 36 is 6 times root of 3yz plus 3 times square root of 49, which is 7, times root of 2yz plus 2 times square root of 25, which is 5 times 3yz. So now I just have to do a little bit more. I have to multiply those. So I have 6 rad 3yz plus 21 rad 2yz plus 10 rad 3yz. And I didn't get as lucky with this one as I did with the one above it because I have a 3yz, a 2yz, and a 3yz. So 2 of these I can add together, those 2. The 21 rad 2yz will just have to stay on its own. So 21 rad 2yz plus 6 plus 10 is 16 rad 3yz. So there you go. So that is multiplying and adding. All right. So if you take a look here, we actually, let's see, don't do any of this 19 through 27. That's rationalizing denominators. We did not do that. Oh, you know what though? Forget this because I forgot I had a different, I did a different sheet for you. So the practice sheet is online and it just has, I think like the first 6 are just simplifying. So from yesterday, and then we did more of that today. And then I believe 7, 8, 9 are multiplying. That's the first part of what we did today. And then 10, 11, 12 are adding, subtracting. So I believe the sheet is called the Radicals Quiz because I used to give it as a quiz, but you guys don't have to take it as a quiz. You can just do it as homework. All right. Well, there you have it. So that was, like I said, your second to last algebra lesson. And we will do solving radical equations tomorrow. Have a good one.